So, what's this about the legendary white wolf?
I made a video clip 6 minutes long with digital audio. Play it 24 frames a second without skipping a beat.
And you guys believe that kind of talk? Waste of time.
You have 64K memory in the BackBit. It's one page of memory that is all you have access to at any given time. How do you access more data beyond the 64K? You tell it where you want to go get data, and the BackBit leaves you alone. It goes offline for a bit. Look where the BackBit gets its data. A backyard pool. We're talking 4 gigabytes worth of potential information. Well, it fills its own memory only, but it does it faster than an REU can. In most cases, it fills up 64K, its own 64K, in about 5,000 machine cycles. So now you have a new 64K that you can stick your spoon in and deal with. So how do you prepare all this memory on this, they call it a BBT file. Now, the first step for me, I took my video clip, and I rendered it as a series of Windows bitmaps, 24-bit color. So now I have 8,730 of these bitmaps. Each bitmap is 128,054 bytes big. And then I created a dummy file that was just a bunch of zeros, and I combined that with my big-ass bitmap glomp. And from there, I have everything I need to start working. There's one last step to do before this BBT file is ready to go, and that is attach it to a disk image. How a Windows bitmap is constructed is quite different than how a Commodore bitmap is constructed. You see, on the Commodore 64, you've got this. It starts off in the top left corner, and it does one character's worth, one cell's worth, and moves on to the next. A Windows bitmap is constructed from the bottom left corner, and it goes left to right, like this. So sequentially, I need to convert what I'm seeing here to what I need on the Commodore screen. And as you can see, it's kind of going to be a pain, right? Old Scooby doesn't like this. And I had to jump around in memory quite a bit the first little while. I turned the 32,000 pixels into 32,000 bytes, where each byte represented a color, 0 to 15, not a color that would fit legally on a VIC image. This is just a number because you can't display more than 2 or 3 colors in a cell or whatever on a bitmap. Well, what I did is took the intensity of these colors and used them as a simple lookup to come up with what you see here. So we have these dark sections and these lighter sections, and they all represent one of the colors that it's actually putting down. Which one, I don't really know. I realized rather quickly that this is going to be difficult to do. A little overambitious. The first 32K chunks of buffers was meant for the breakdown of the final bitmap, which I now plan to do later. But those intermediate sections that are 64K in size, 32,000 pixels, 2 bytes per pixel, and now an entire video frame conveniently fits on one BBT fetch. Now that was important because now I can bring in a whole frame at once and chew it up any way I see fit. But I think the second time around, because the colors are different, you see, because I don't have a final color at this point. I wanted to do this 2 years ago, but I was unable to convert the bitmaps I had made at the time to multicolor character sets. And there's one good reason. Yes, it was the RetroPixels program, because I used that program, somebody else's program. Now I'm stuck with the decisions that program made. You have one global color for the screen and 3 unique colors for every cell. Well, in a multicolor character set layout, things are quite different. You have 3 global colors common to the screen and 1 color per cell that is limited to 0 to 7. The biggest hurdle, if I ever pursue such a project again, is not to rely on the RetroPixels program. That program is great. The big problem was that I relied on it, and the other hurdle was, well, think RGB. You've got 3 values, 0 to 255. Think of a cube, X, Y, Z. Each value is a axis on this cube. You need a way to find out mathematically this pixel is closest to which Commodore color. You're talking 3D Pythagorean distance formula, which is basically the root of the x difference squared plus the y difference squared plus the z difference squared. Are you freaking kidding me? We have the locked-in colors here of number 10, which is pink, 13, which is light green, and black, which is close to 0, right? Whatever. Here's our mystery pixel. Jab it in there. There we go. What color is that? I don't know. So what we do is we use our little tricks here and we find out how far away it is to every one of these things. And that's basically it. The lowest value is the one it's closest to. And look at all this leftover clay I got. Yeah. This model sucks. I'm sorry. So let's start with 2 sample points right there. And so we got to figure out the distance between them. Well, lucky for us, as you can see, they're rather low numbers. Why? Because now we're dealing with XYZ values that are only 5 bits in size. Our X difference, check it out. Boom, pre-calculated squares. And you do that for all 3 values. Use the same table, of course. So the maximum size for each of these squares, 31 squared, is, what is that, 900 and... Oh, I should know this. 961. That's right. So 961 for each component, and well, 961 times 3, 2883 is your total. So use a different table of pre-rooted calculations, and there's the distance. Easy as pie, isn't it? 32 simple values, and I basically take each RGB component of the cell in question and I add its associated value to each of the RGB values. So some values get brighter, some get unchanged. Let's start with 1 pixel. Here's our pixel. Yay. First we check it versus the 3 locked-in values that I've pre-selected. And then you have to also check it against all the other low possible values that might be in that cell. Because you don't know which of those 7 other values is going to be the color candidate. You don't know yet. The whole problem here is figuring that value out. But for every one of these pixels, all 31 of them in the cell, we have to compare them all to white, red, cyan, purple, green, blue, and yellow, all of them. And yeah, okay, so we run this algorithm a whole bunch, a bunch of lookups. But, well, take a peek. This is how much, look how many times it needs to do this. I'm glad I was able to use simple lookups to do this because, wow, it is insane. Say we're going to use white. It's either going to be white if it's closer to the pixel in question, or it's going to be its fallback color. Either way, we use the lowest value and add it to our tally. And we add them all up for every possible pixel choice. And as you can see, blue's the winner here. Everything that's closest to black, everything that's closest to pink, light green, and now blue. And take a look. Take away our locked colors because they're not really plotted. They were just mathematically there. Here are our 32 pixels now. See? I've locked in colors, I think 1, 5, and 13, just so I get the best grass, and of course a little goat buddy here. Just like the last program, this here is trying all the global colors via brute force and showing me what they look like. By jumping through the video in larger sections like this, I can easily check out a certain color combination myself and get a feel for what it looks like in different things. This is the same evening, about 3 hours down the road, and as you can see, I've already made some progress here visually. It's kind of cool. So I thought I'd give the brute force thing another chance. And here we are. It's whittling down the global color choices mathematically, finding the best, what it feels is the best combination to use. And in the end, it chooses colors 8, 12, and 15. Well, surprise, surprise, 2 of them are gray. And so it ends up making a picture like this. So I thought, let's try these colors instead. And you'll have to agree, this looks better, does it not? And of course, I had to do my test renderings with the SuperCPU on. That's why you're getting this interference here. But, I couldn't wait. I just want to, dash out some colors and see what they look like. Here's what it looks like when black is set at the default zeros. So I slowly made changes, adding 1 to each RGB component that it considers to be Commodore black. And as you can see, simply by changing this value, the image gets more and more black because more colors get resolved to black. And as you can see with his nose, it looks good. The shadows become more pronounced, and eventually too much is too much. But this is possible with every single color. Just because black is close to 0 doesn't mean it needs to be there. I can make it the equivalent of red if I wanted to. Every color is tweakable.
This is the second close-up of the blue wolf here, using locked-in colors of blue, green, and light blue. Light blue is included because the program won't be able to pick it directly because it's confined to the first 8 colors. But as you can see from the detail on the snout in particular, we got all 3 colors in play. And the fact that green is one of the colors helps avoid jaggies along the contour here.
Eventually, I added these sprites that show the frame number in question and the 3 global colors that are assigned to that frame. Well, you have a bitmap. It's 1,000 unique cells. Now, sometimes there are repeats, so let's say it's 800 unique cells. And you want to pull out 256 of those to shuffle around and copy or whatever, and try to recreate that bitmap the best you can. How can you do that? How many variations are there? This is how many possibilities there are of pulling out 256 characters from a pool of 800. Can you still see me? Yeah! The concept of pixel difference, and that is where you take one cell of the original bitmap, or a character, whatever, and you compare it to another cell of the original bitmap or another character. 32 pixels versus 32 pixels. Now, there's only 4 choices for every pixel here. These are multicolored pixels. 00, 01, 10, 11. So just add them up. How many match? Or more importantly, how many do not match? Because the pixel difference is the main metric on how almost every decision in these programs is made. And how effective a routine is weighed down to a different value, the global mismatch. And that is where you take the character set you came up with and the 1,000 cells of your video matrix, and one by one you compare them to your original bitmap, adding up all the pixel differences. That is your global mismatch. And the lower the number, the more effective the routine you came up with.
Yeah, screw it. I'm going to try a different frame altogether. Of course, the first time around, it's just upping what was set by basic. So once it gets to, I guess, about 5,800 or so, 6,800, it's going to start looping from zeros. Because I just took over the sprites internally to debug this stuff. It is currently 10:37 p.m. Let's see how long this image takes. Ooh, big jump right off the bat. I like this. The screen is set for 4400 hex. The character set is set for 4800. No, 5000. Because 4800 and 4C00 are both my pixel difference matrix and the work flags, used flags. These sprites are at between 4000 and 42C0. As the algorithm is designed to do, it takes every possible new candidate and pretends, what if it put it here, put it there, and it'll choose whichever candidate has the greatest number of cell mismatch improvements. It's not looking too good. That's too bad because I have worked a long time on this. It's kind of a bummer, but that's the fun of doing a project like this. Just chasing your tail. But then again, I got the colors backwards because this is supposed to be dark blue. This is supposed to be light blue. Okay, this guy's getting a bad case of acne. I'm not sure if my program is working correctly. And here we go with a new image. It's currently 11:33 p.m. It always starts to go batty, so that's actually good news because maybe my routine is well, bugged in some way that's actually taking a lot longer than it could to execute. I might actually get this working, and I definitely need to optimize it. And here's what that same image looks like in my video player debug test thing.
As time goes on, I use this. Version 1 is my big benchmark. If you can beat version 1, you're onto something. So begins the long journey of finding a better solution. And for me, finding a faster way of doing something you already understand is, it's great fun. This is one of the most frustrating and fun challenges I've ever had to do in my life.
This isn't perfect yet. Well, it is a lot of fun to watch this thing draw itself. But as you can see, there's this chunky stuff. The overall pixel mismatch is not that bad. There's only 32 possible mismatches. That's if every cell is absolutely different. Super CPU time. Without it, it's about 5 minutes a frame. Well, yeah, you might be wondering what the 744 is all about. Every time a cell gets basically disregarded, it's now merged, it's now gone. Well, once 744 of the 1,000 are gone, what's left? 256. And once we hit that number, then I know that every single cell left can basically be encoded as it sits, completely uncompressed. You don't have to worry about it anymore. This here, I have a different picture I'll show you. They didn't appear before, and I have a higher mismatch total.
Wow, rainbow.
I add a little bit of code in here, so as you can see, all the little Spazz Out Squares, these are where the 256 cells that generate the image are coming from. It's going to print a character and then fill the screen with every occurrence of that character and then move on to the next. A lot of the beginning characters are unique. Look at that. It's not for a while. Well, there's a few until we get to the M and the N that there's many of them. Neat. And of course, each one of these super repeated characters help knock down the original 1,000 cells to a manageable 256. This is how this compression works.
These are the 256 cells that remain from the initial 1,000. They're sequential because it's not until you're down to 256 does the pass go by where it actually gathers them up into a character set. So after we have that, we have to create the screen, create the video matrix using those characters. So we start with a video matrix that's basically a blank slate. The pixel difference for every cell in this video matrix is starting with a default value of 33. That's because no matter what you feed it, no matter what you compare against it, even a gibberish square is going to have a difference of 32. So the very first character that you're using, character 0, is happily put down screen wide. And then it moves on to character 1 and it tries to put it everywhere. And if it's better than what character 0 provided, it takes that place in that cell. And then character 2, character 3, and so on. And that's why you can see the image build itself, because it puts down the current best for that particular spot in the video matrix. And it keeps revising it because it comes up with a better one. Goes, oh, hey, this is better than this. So it tosses that and writes over it. That's a short one, isn't it? It's not the first time I've heard that. The quest is speed and precision. And the problem is my very first one is slow as hell, but really good. So can you find something that's fast-ish and really good.
Come on. Oh, look at this beauty. It's not gobbling up all my characters yet. And I know I can go back in here and improve this. Ooh, damn. It's faster, but it's not better. It might overflow, lock up, screw up, who knows. What once took a half an hour. Ooh, I mean, not well, the ending time doesn't matter. Why doesn't it matter? I'm not sure what I did wrong yet, but wow, check this out. Just look. Once it hits like about 300, it starts finding and replacing characters like it was designed to. Check out the snout. Boom. Oh yeah. And it's improving itself as it goes. And then when it gets to 1,000, well, that's when it gives up, right? Oh, please get rid of that dot in the eye. Oh no, it's wrecking stuff. But it's also thinking that this is part of the image. I'm not sure what's going on, but it's wild. And it'll start homing in on the ideal picture. Problem is it runs out of characters. Doop-a-doop-a-doo. This probably is not a good solution, which is too bad because I spent days on this. Ooh, what a waste of time. It picks 256 different cells from the bitmap, calls it a character set, and then sees what it can do, making the best of it. And as you can see, youch, it sucks. Once it hits that magic number where the unassigned characters equal the amount of cells it hasn't dealt with, watch this, it's just going to pop. Boom. Isn't that great?
After all these fails are out of the way, what's left is the one that works.
I'm still working on this, of course. This is now Character Maker 7. These are the first 256 unique cells, and the image does the best it can with those, assuming that was its character set. Well, we still have many more candidates. Now, what it's going to do is take the next, say 349 or whatever, the next character, wherever it is in the bitmap, and it'll go, let's consider it. And it'll pretend, well, if I put it here, which ones does it improve? And at the same time, it goes, well, which characters does it make worse? So say it ends up replacing character number 1 in the character set. How would that affect things? Character 2, would that make it worse? And it does it for all 256. If the lowest loss is less than the gain of using it, that number 74 gets punted and we replace it with that one. But that is a lot of work. Many, many comparisons. Haha. But I have a way around that. I wonder what's wrong. Oh boy. That should have been loss high byte, X. I fixed the bugs from this morning. Once this counter gets to 348, that's when we are in new territory. And here we go. And now every flicker of the border is something getting replaced. This might be it. This might be. And it's starting to look like it's the best solution so far. Oh, we're almost done. We're almost done. What do you think? 1386 is the score to beat. 1376. Not bad. I really wish this thing was Super CPU compatible. You can imagine how quickly it could power through 9,000 frames like this. "69 times faster."
So now that we have our Character Maker program, we're going to have to put it to work. We have thousands of bitmaps to turn into character sets here. All we do is load in the bitmap frame, convert it, and then write 4K back to the BBT, a character set, video matrix, and color RAM. And we put them in the same 32K chunk of, the BBT where the original bitmap frame came from.
So this picture should match entirely the one that is produced. For some reason, the colors weren't happening and it was all screwed up. And I realized, because I stored them in the color RAM. Yeah, that's all I needed to do. Are you kidding me? And that truly is the frame. So now I can finally get this sucker started. Oh, man, I feel sick, but I know it's going to work. It's been running for an hour and 45 minutes. Hey, what do you know? Here's one of the frames that the Super CPU buggered up. It's one of the rare times where the Super CPU optimization mode will come in handy. The optimization mode on the Super CPU is just a series of pokes. 3 pokes on the way to this routine and 3 pokes out of it, so at least my basic results get mirrored to the standard memory. The bottleneck is 1 byte. If you end up writing to that 1 byte like 2 times in a row, it's like cars going through a tunnel. They have to wait for each other. I am saving heaps of time. This Super CPU has, saved the day again on a super time-consuming project. Even the Commander X16 would not have been able to do it this quickly because that's only 8 megahertz. Well, I don't have one yet. It's going to finish while I'm at work. And then begins the slow task of fixing all the mistakes. Now I can hit return on it and wait my 5 minutes. Oh yes. I'll always stay on this level where I can look at frames and affect them. Okay, so now that's a corrupted frame, right? So it's 67. So what I can do is press F7 on it. There, it's logged it, right? Doesn't mean it's fixed. It just knows, yeah, get around to it. Man, there's a lot of them. So what I can do is run through here, flag a bunch of them, go to sleep, and have it busy fixing things while I'm gone, you know? I mean, the program's evolving. Let's see what this data really is. Ooh, what is that mysterious thing? Okay, so we get a big-ass series of 219s. And coincidentally, the character for it is 0. Guinea pig number 2. This is what it kind of is supposed to look like. And this is what we got. So why was that section black? Because 8s. A multicolor 8 sets the 1-1-bit pair to black. DO21, 22, 23 all set to black. Got some nastiness occurring in real time here. Oh, blue wolf incoming. I know this part. There he is. Ha ha! You got a very dark gray snout.
Oh, macro wolf. Oh yes. Ooh.
Look at his eyes. You can see how they're just a smush, right? Because the program doesn't realize that eyes are rather important. Check out how clear his eyes are here. See how eye-shaped they are? I forgot what I was talking about. Doesn't matter. Okay, Joe. I plan to copy all 8,730 frames to a humongous file that I can read back with the Super CPU on at 20 megahertz and deal with there, and then write it probably to the BBT. Hopefully it shouldn't make any mistakes. And that's not supposed to be going on. We're finally going at it. I've taken the plunge. This is writing every bitmap to the SD card. As I'm bringing it in from the BackBit, I'm doing a JSR FFD2, which, thanks to the CMD command, is spitting it out, hopefully, to the SDTIEC. Let's check it out on the computer. Is it actually 77 megabytes? I love these guys. It is exactly the size I expected it to be. That's good. Now we are redoing all 8,730 frames because it's now reading it from here, writing it to the BBT. Watch the quick blink here. Boop. And the Super CPU is obviously on. Look at this. Yay. I got a feeling that even saving in high speed to the BBT is probably problematic. In other words, if you want to mess with a BBT Super CPU, you cannot play along.
This one kind of pissed me off.
Christmas morning, 5:47 a.m. I thought about putting a pause. Watch this. I gotta just let this problem go. These are the best we can hope for from these images. But as a character set, they get kind of trashed because they're trying to compete with all the foliage. And that's the latest, possibly last problem to do with the character set that I'm going to try to tackle. Kind of reminds you of War Games, doesn't it? Okay, Character Maker 8.03. This particular sequence is really good for showing this guy nice and big and clean. So I'm going to look at some earlier stuff and see how bad Gabu's eyes are. But they don't look that good after all. Oh, come on, that better not be like that in the end. And it probably is.
And I'm going to sneeze. Check me out. Oh. Is he going to come or what?
20 hours after I started, we are less than 10 seconds into the video. Yeah. Okay, so I've already made the big file on the SD card, but then what I did is I saved them to the BBT. Well, screw that, because that makes mistakes. Save them to another file on the SD card. It's busy saving. And this is the very first frame. This thing is out of play. This thing disabled. I'm trying to pin this sucker down. It was doing it in high speed, but then more and more I was getting frames that were just complete nothing. As it is, what's this? Oh man. I opened these from BASIC, and from machine language I'm just calling the check-in and the chair-in routine, you know, and then the check-out and the chair-out. Easy enough, you'd think, right? I don't understand serial disk access very well. This time around I added a JSR clear channel FFCC after I'm done loading or saving portions of code. I haven't made a note since the 90s. Well, as you can see, it's working, and working well. This is the character set, video matrix, and color RAM as pulled from the file I just spent 2 days making. This is absolutely as fast as the SD to IEC can go. Seriously, this is all you get. These are going to be glitch-free frames. All right, if you look carefully down in the corner here, you will see the frame number before it gets saved to the BBT. These are them. These are character set, video matrix, color RAM, all saved to the 13K mark within each 32K zone allocated for each frame. This is just a patch on an old hack of it's a mess. This particular player. Imagine this at 24 frames without any glitching. Yeah, it's still down the road. Happy New Year. Yay. It's January 1, 2024. And I like how fast this is. Like, look at this little Blinkosaurus. Boop, boop, boop. Now, you might be able to see these frames changing. Barely. Oh, man. It's hard to explain. Even thinking back, as I was putting it in, I'm like, what does this do? And I fudged what I needed to fudge, and I trusted myself that it still works. But this is pretty much it. This is the whole routine of what it's doing. Look for zeros, find them. Da-da-da-da. Even though the pixel difference is supposedly better, I don't know if it's worth waiting 2 days for.
Tell ya, you relieve yourself in the fish pond once, and they ban you for life.
I was not expecting 5,000 bytes to be different. And that is going to put me in a big jam, at least bitmap style. My secret weapon is not going to work. Pretty much the entire character set is different. as expected, see? Because the frame changed. And so many color things got changed.
I'm going to trim anyways. I like fur.
8000, A1000, C1000, and E1000. And it doesn't realize that it's actually chomping down 4 frames at once with one character set to describe them all. So BASIC's running in a little tiny box, and the rest of it, my assembler's been overwritten, everything's been overwritten. It's nasty. That's what it's supposed to look like. I'm probably going to stop the keyframe making process. It's kind of slow. The quality's pretty bad. Now it's here. It's documented for eternity in case, I want to get back to it. Who knows? This is redoing my frames again. Only 128 characters per frame. I don't think I'm going to keep it, but since I have really nothing to do with this computer right now, I'm going to let it continue making it. 19th and 20th kilobyte sections of my 32K buffer. And even this guy, he showed up. He looked pretty good too, but at, 1 frame at a time, you can tell he's jig-jaggy because, he's missing half of his characters. Okay, here's what I've made. I created it on the screen. I copied it here. Basically, it's a bunch of incrementing things on a page. And then I have, what do we have? Well, I'll break in and explain this better. Take it over, Loop.
Pussycat, pussycat, I love you. Yes, I do.
So here is the code that it's generated. This one here, a DFFA, the first thing it does is change the page on the BBT, switching it from the 0th page to the first page. Jump DF100, which will take it back. It switches to yet another page. Hopefully you'll understand this better with the graphic I hopefully have made and showed on the screen. Okay, I think this is the code I want to save to the BBT here. It'll just increment stuff until it gets down to the NOP. And then this is 65, which is page 101. So it instantly will switch to the 101th page. So it skips this. Jump DFFD never happens. And when it gets to the 101th page, it immediately is executing this. Jump DF100, it goes back to the beginning. And then it lands here. Does the increments for the 500, switches it to the 102nd page, and then immediately executes this next. And then goes back here, does the 600s, increments the border just because, and leaves. This should work. Yeah, I know I said I'd start on this, quote, tomorrow. Well, it's been 2 days. I'm still sick. This is all it does. We're setting it to page 100 by poking and starting it running. And then when it's done, it plops back and does it again.
I gotta start to write code that writes code.
Last time around, at 5,000 cycles per queue up, it was waiting approximately 45 seconds for it to do all the queue ups. That still doesn't explain why it ran over like 2 or 3 minutes longer than it needed to. No, it seems the original version I showed you guys was 8.5 minutes. So I had to go and investigate this timing discrepancy. I borrowed my old code that counts the cycles during the wait delay. This is not making any sense. What happened to my 5,000? So this turned out to be 3.5 minutes of queue up time, whereas this was a little over 1 minute.
Saskatchewan, Canada, where you can watch your dog run away for 3 days.
Some work done on paper, well, a lot of, what do you call it? Well, scribbles, really, because none of this is going to stick. But you have to get it down on paper. You have to get your ideas down. Otherwise, you can't just sit in front of this thing and dash out some working code. The first things it writes directly to 3 different buffers, the DO21 color, DO22, DO23. And then we just write everything that is a 0. And these 2 items have to be in the same video bank. The color is 512 bytes that can be wherever I want. And as you can see, we're getting closer to the end of a page. Now I changed how the pages end. See? I fill the entire area with RTSs. So as soon as this instruction would not fit here, because this is actually going to be the DF100 page. As soon as it gets to this one and it has no more room. It'll execute the RTS. I'm going to let my main program switch the page on the BBT and then probably JSR DF100 to get back in. That way I'm not locked into committing myself to a certain BBT page, by STADF something something, right? And I made sure previous frame is all 00000, so everything in the color RAM to B doesn't match, so it makes certain to write all those at the first time around. And then that becomes the old frame, comparing it to the next frame, and most of them will match, at which point we can start getting creative and doing some skipping. 4,000 to the 6C100 page has to get copied to the BBT, and that's what runs later. You can fit 5 frames, one exact chunk of 5 frames, 5 buffers, can be filled from one BBT fetch. This counts. Like right now, say 90. It's looking for all the 90s, making that list like you saw. It's creating the code, and it's doing it at 1 megahertz because it has to. That's it. So none of the color decoding is in place. It's only doing these first 4 or 5 buffers and just looping them. See? This is exciting because now I get to make the code that actually plays the thing. I was about to give up on this because I could have sworn it wasn't working. My color unpacker does not work. I figured out why my color is crashing. Anytime it sees a positive value in the unpacking stream, it uses that as the next offset to go to. Anything that's a negative gets plotted. Yeah, so anyway, what did I do wrong? This is taken as the next offset. So it just goes boop, 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 and it never finishes. It'll read this one and it'll say, oh, that's a positive. So it'll jump to 2. Negative, it'll write those 2 colors. Same thing with here. And now this is a 5. Well, big deal. It jumps ahead 1, right? But now it's an 18, well, a 24. And it'll jump here. 2C jumps to 2C. Does those colors. 4B, you see how quick it is on the unpack? I spent some time tonight speeding this up. So most of the time, it's doing just this. You can see that this is clearly faster. So, I mean, it's about 12 seconds now.
So we have the rolling out one more time.
So assemble away. And I haven't done anything else. There it is. I bet you I can get this thing playing fudge-wise, probably before midnight. You run away, you do this, and the screen's going to, it's going to crash. It's going to crash. Yep. Damn. Because it doesn't know when the video is over. Nice. Well, I don't expect this to work. It is 11:54. It's probably just going to crash. And if it plays, wow. I guess I'll try to fix this and maybe see if I can do it in the next 4 minutes. Here we go. I just stuck in this line, so it's going to, as soon as it tries to unpack the color, it's not. Hey! Hoo-hoo-hoo! It's my color unpacker's pooched. Okay. Damn, that would have been pretty. I got 3 minutes. Maybe I can fix it. I have about 70 seconds left in the evening. This is going to work. Ah! Don't. I'm long since blown my deadline. You dumbass. Those are the low bytes. Oi. Well, we're back to poking along at this.
That's kind of the problem with this rollout thing. You make one mistake in your code or whatever, you've got to spend another 36 hours fixing it.
Here we go. We ready? I'm scared. Oh. Haha. This is really it. I don't know what to say. Should I be saying stuff? Well, I mean, you're watching this. Commentary. Well, what I can tell you is I have the interrupt structured where it's counting down from 2 and then introducing a frame, then 3, then 2, then 3, then 2. But anyway, it looks to see if the buffer number, if it's 0 to 4, it just waits. And once it hits 5, it fills the 0 to 4 section. Not a crazy bunch of flickering, isn't it? 1 megahertz.
Check it out. Sundogs. They're like mini winter rainbows.
It isn't very obvious at the moment, but it might become soon. You see, some of the color is glitching, and I don't know why. Is my color amp toast? What is this? What is this? And you see? Half a page. It's got to be some sort of clue. If this area is getting written to randomly by something else, it is plopping something in the middle of a color buffer, and it's going to depack it in a strange way. I'm going to be seeing little flashes of color that are wrong for the rest of my life, I'm sure. Like, what was that? Did you see that little cyan bit on his body? Yeah, see, that's not supposed to be there. These are the character set frames that I believe I ended up using to make the rollout. So we're just going to up that to 5. So it'll be 5, 6, 5, 6, 5, 6, right? Okay. So now it's got plenty of time. When the Wolfie comes along, you are not going to see that piece of green on him. That every clip, see? Nothing. So this has something to do with speed, and it's not like it's too fast for it. It is tripping over itself somehow. I am even getting some color glitching with the Super CPU, and I'm surprised a single byte has not derailed it yet. Check out the wolf. There'll be no green. No green. Slow it down. Now we'll get green on the wolf. See? It's all something to do with the speed. I am not getting a single crash due to it reading corrupted data. Now something occurred to me here. What this is doing is running rolled out code from the BackBit. It's bringing in the data that I'm requesting without fail. And here I am, since I'm executing it from the BackBit, I will never have the Super CPU stick its beak in the way and wreck stuff by bringing it in through it, like the middleman. So if that's true, what a bonus. Because I'm going to play this several times until it either chokes or I get bored. Next test, I am going to take this out and we'll see what happens there. Because, yeah, look at this nonsense. Yep, still pooched. Okay, whatever. I guess I finally do get a good night's sleep. More like a good morning's sleep. Right. It's nearly 4 a.m. The white is the raster interrupt. And then it takes the current buffer number at that point and puts it in the background color. Well, I can't show you, but adding one screen refresh to every interrupt and there's no color glitching. That is still the biggest clue. Look, he's nice and clean. Everything's clean. If I simply slowed my video down to this frame rate to make it work and called it a bug fix, it's not a bug fix because I don't understand why it's doing it in the first place. You see what I mean? I need to know. It has to make sense to me. 5:10 in the morning. Another thought to go on. Because this logically should continue the flow. But when it's a 2-3-2-3 pattern, you almost always get it. I think I solved my problem. I'm going to go home and this sucker is going to work. You won't believe it. Watch. No green. Ta-da! I want to fill buffers 0 to 4 and 5 to 9. Now, quick fill originally was a double routine. It would fill 10 buffers in a row. I wanted my main loop just to be able to call it as well. So I turned it into a single where it only does 5 buffers at a time. Thing is, I never fixed it earlier. It's not filling buffers 0 to 4. It's filling 5 to 9. But in two screen refreshes, it's already supposed to be displaying buffer 5. And it's not even in memory yet. But if it doesn't fill frame 0 entirely, by the time it's due to play, when the packed color buffer is neither here nor there. It still is impossible for it to loop on itself endlessly, and it's also impossible to not eventually make its way to the 127th character. But in the meantime, it's plotting stuff that 10 frames ago might have been there, because it hasn't updated that and covered it over. The interrupt don't care. It sees that, it executes that. That is the mystery of why colors sometimes appeared where they shouldn't have. So why does giving it one extra frame, why does that make all the difference? I'm giving it more time to complete that very first buffer before it's told to display it. So here we go, 20 megahertz, and is only given it one. Well, look at it go. Now they'll be glitching because the same effect is still happening. The interrupt is just going frame 1, frame 2, dun, 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 and it doesn't care what's there. It doesn't care if it's ready. Now we'll do it at slow speed. You see that? And you can imagine these are the frames of zooming in. So it zooms in what it has, and by then it might be a frame or two forward, and it zooms in and it shows what it has again. So it's glitchosaurus, right? But understandably so. The old character set is carried over. Right off the bat, it thinks, oh, that's going to make a great Gabu. Well, no, he's changing in size and everything. So it's neat to see it just slam him down and then have to fix it. The 21K marker in my 32K buffer. These pictures look bad. Maybe I'm getting spoiled. It's exactly the value that I used to get, 1376. So yeah, there's no point in even rolling this out and continuing because it's exactly the same. Exactly. This is exactly the same. It's the same fucking thing. But now I know the answer. There's no point in feeding it the last frame to create the next frame. Want the possibility of using two character sets. So for fun, I made it do twice the work it's meant to. 512 bytes packed color. 3,500. This is what happens if you try to get 7,000. It's not going to work. So that tells me this is beyond my upper limit. I guess through the magic of editing, ta-da, here's a split screen. Yeah, see the difference? Okay, well, I'm just saying that because I really don't see the difference from here. Okay, here's what I'm doing. 20 frames a second, so it's a 3-3-3-3 pattern on the refresh. Are we going to get corruption? I bet you we are. Sure. Too much work. So next step for fun, let's make it a 4-4-4 pattern. 15 frames a second with 7,000 bytes per frame. What? 6 frames a second. It's now a 10-10-10. Come on. What? Okay. This is definitely my fault. I'm screwing up somewhere. I gotta find this out now. I created a mystery for myself. BRB. Let's say one line on the screen is one line on the back bit, right? So we got store anywhere we want, and then say load A with 6. Store. Load A with 7. Store, RTS. And then we JSR that page again. Well, duh, you idiot. A was 5 when it began. It changed to 6. It's changed to 7, for example. Now we go in with a value of 7. We're 7, 7, 7, 7, 6. Making things set or 6 again. You see what I mean? It's not designed to do that. Although I can. I can make it semi-do it, wherein save the value before you... Oh, clever. Okay, here's the scoop. Take A, do the JSR, right? Pull A, do the JSR. It hurts being this clever. Here we go. What? No way. I am Surprise, this is 7,000.
In the daytime, I am totally not scared to be under here. You know, like cars go by, I feel rather safe. Yeah, and it's a good place to take a leak if you have to.
I guess I should document a little bit of the creation here. And here's why I'm going to print this out and study it. Ooh, neat. Scary, but neat. Okay, so here's where one of the major problems lies. Increment Y. When that wraps, I have a special routine just to come down here and increment the things. When Y wraps 255, it's never going to be at the very end of the screen because video matrix plus 1000 is not evenly divisible by 256. It's ending in something 24 shy of that. So I never even have to check. The end of the top section is line 12. But that ends at AF00. Well, that is going to be an even page on the bitmap. So 3880, you go here, increment it, deal with Y, but you're not going back to check. Are we done? Because we just scuttled off. Because this is the one instance where the bitmap page does wrap when you're looking for it. So in the end, Y just goes boop and it carries on. And then these things continue to get incremented because it's never going to find this. It's nothing but chaos. I think I got it working. You see, the first thing it does, that is pure. That is directly from my original bitmap. 640 writes just for this one stripe. As long as I can play the audio at 8 kilohertz, I'm going to call her quits at that point. The amount of characters per set to 235 or less, the rollout will not exceed 64 pages. And that way, well, duh, you get 4 frames per BBT fetch. And this wolf looks frickin' adorable. I mean, he looked good before. Now he looks more good. More better. Stupid program. I love it. This is likely going to end before bed. There it is. Yeah, guess which one I just made, eh? It's saving these character sets at the 24 and 26 kilobyte markers. It's been running for about 18 hours. I'm not exactly sure. But no, whatever. It'll be done in the morning. It's looking good, though. I like these eyes. What do I have that can play this? Nothing right now. Well, I couldn't resist. I just changed the values I need to change to bring in the top character set. And it's looking good. You see this? All the stripies? I know why. I know why. If the highest bit of the location you're saving is set, clear the high nibble. Because the only thing that was above 8,000 before was the color RAM. Congratulations, doofus. You screwed it up. Well, since I'm only going to be doing the bottom, I'm going to move the sprites up in the top. Anytime you've seen numbers on both sides, these were 1 pixel down. Well, yeah, something I never even explained here. You see how it goes there? It goes to 480 because 480, 480, and 40. It doesn't count these. It doesn't count those. And the first little bit is the, see that? That was the dupe check. 26 kilobyte marker. It's just this one. Bottom C set only. Yeah, whatever. You do your thing. I sure hope it's writing to the right section or I'm wrecking a BBT. I will never, never, never need this program again. And I could not resist. Frame number, the regular, what I was getting before. Once the merged version, you've seen me merge it. This, at first I thought was an error. Oh, it's not. It can't be. It isn't. Wow. Look how much better it is with 2 character sets, right? This is basically it. We start at the bitmap. We start at the video matrix. We take each character in turn, find out where it is in the character set, do a comparison against its original bitmap piece, add the difference, keep track of it until we get to the end of the screen. That's it.
You got a token?
There we go. And what's it doing? It doesn't fetch from here. It's getting it from the BBT and saving it to the BBT when it's done. But as you can see, watch it count up there. That's when it's creating the rollout code, when that is moving. That's how fast it does it now. Of course, after you see the image, that pause where it's zeros, that's it actually doing the sorting. So yeah, my high-speed bucket sort works in high speed. And this is off because it has to be, so that's truly it. Look how quick this thing is. Now, through the magic of editing, let's check out how quick it used to be. See? Was slow. But at the time, I didn't realize that it was a sort routine that I was basically pulling off, and now it is quite fast. Okay, after a few hours, I'm ready to go. Will it work? I bet you it won't. Ooh, it sort of works. This garbled screen tells me I've got one of my buffers wrong. Did a quick hack and I changed every single buffer value to the first pair, these two. But I was going to do one at a time to see which pair is messed up, right? And of course, the color is getting it from the proper place, so it's kind of like a glow. It's not really following where it should. That's okay. That's not the problem here. Wait. This is how you debug, right? You think it through and then you fix the screw-ups. Bingo. Or at least one of my bingos. Nope, this should be right. This one seems to be messed up too. So I have this new thing called Watchdog. So while it's showing buffer 0, showing, because current frame is now actually displaying, it'll loop. And once it's done looping, it goes and fills buffer 0 immediately. But here's where I screwed up, because this fill buff goes and deals with the buffer that it wants to just fill right now. But it's not going in with the Watchdog value, it's going in with the current buffer. Simple fix. Look at this. We put, Watchdog. That's it. Please work. Oh, beautiful. I tell you, understanding your code is the key, one of the big keys to debugging. Now this I've got to just make during the initialization, solidify that in every video matrix. Obviously the code that follows the player and tries to execute BBT code to fill buffers. Obviously when the video is over, there's no more code to execute. So I put in a trap here. It's going to look at the first instruction that's due to be executed. And if it's not an LDA immediate, it just skips it. So are we going to get back to basic nice and clean, or is it going to hang? Let's find out. We're seconds away. Whoa! Maybe I'll show you what I got from months ago. But yeah, I'm about tonight. This is February 17th, just after midnight. But I'm about to snag the audio.
What? Look over there! What? I would never.
You see how it's nearing the maximum loudness or whatever. This is how you do it. You get them to tell you exactly how to do it. And yeah, so it says to do this: split stereo to mono. And to delete one of these channels. Well, I didn't, I think you just do that. Yeah, there we go. Now I got a mono. Cool.
Sure. Wolves eat berries.
They sure do. So now I got to figure out the bit rate. I believe on Wolves in the BackBit, it was 131 NMIs per frame, 60 frames per second. That is the amount of samples per second I want. So for that, audio setup, audio settings, There, I put it in here as other. And this is what it sounds like.
You like that at all?
I wonder. I bet you thought I would be the tastiest goat around.
That sounds pretty bad. Unsigned 8-bit PCM, whatever PCM is. We just want 0 to 255 and then we go from there.
Okay, on the left side obviously is the single character set version, and on the right side is the 2. I was rather surprised to see the difference, not as obvious as I once thought it was. So instead I made this different type of split screen. The wolf should look crisp and clean a little more than the goat's side of the screen, and the grass on the right half should also look a little less flickery.
Doing the rollout for the Digi Audio now, and it's using the quick sort. You start in this direction, you find something that's less than 128 and you remember it, and then you go in this direction, you find something that's more than 128 and you remember it, then you switch them. And and then when you get to the midpoint, all the 127s and below are here, 128s and above are here, and then you can pick this gap and sort it. I forgot, I'm writing to a BBT. No bad. We are now about halfway in the middle of this. Look how slow it is. Come on. My quick sort is a tortoise sort. Sucks. Ha! This is an interesting whatever. Of course, it never works first time. Neat. I don't know what it's doing, but it's cool. And then it gives up. Once again, I'm reserving the X register for exclusive use during the NMI. The rest of my code better not be using X at all because I don't save it, I don't restore it during my interrupt, nothing. And I also don't restore or save the Y or A registers. So anyway, we basically get a byte that's already Mahoney converted, play it, increment the low byte, and on the rare case where it wraps, otherwise we just acknowledge the interrupt and leave as fast as you can do it. This is what I was so proud of earlier that I didn't show you. This will set the carry flag. If it's under 7400, it's clear. If it's more, it'll be set, right? At which point we just take a 0 and roll it. So now we're going to get 0 or 1 based on where were we last time. And if it's the same, do nothing. But when this changes, when basically we cross from one side to the other or back again, at which point we save the new copy, queue it up on the BBT, and fill it. And the fill routine is very, very simple as well. Basically, that's it. 37 pages. Start at page 0, execute it. 37 pages later, we're done. Because of where the audio begins, this is actually filling the audio buffer at the very, very end. It's an interesting bug that's caused by this. When it's looking into the future, it does see the beginning of the audio rollout, but it's a different beast altogether. It does it 64 pages at once, not 37. And so at least that explains why my audio buffer is getting filled at the very end. But that doesn't explain why it isn't playing at all. Why it isn't filling at the beginning. That's the next problem. Why isn't it filling? My good friend incrementing color thingy says something is wrong. Another thing I don't like, because I'm a stickler for elegance, you see how they're not sequentially listed? Because that's a side effect of them being shuffled and then shuffled further and refined, and they're branched in weird ways because of the quick sort. Why does it do that? Serious? But why isn't it working? It sounds like a cheap helicopter from some old game. Yeah, sucks.
You're pretty busy looking this way and that way, kiddo.
Crap. No, it's not. Okay, I set the frequency to 129, right? No, because that is just, it's taking it as the location. Well, guess what? What's in location 129? A value of 32. So I've been setting my NMI frequency to 32 cycles between... Oh, yuck. There. I know I can get this thing playing from disk with the Mahoney tables in memory. It plays it slow, but it's the proper noise. So why isn't this the proper noise? All the digging around tonight I've done, I've come to the conclusion that the rollout somehow is corrupted.
You know, it still blows my mind that the Commodore 64 can do digital audio. And if it wasn't for Mahoney, the fellow that discovered this technique about 10 years ago, this project would not be possible. His method makes digital audio on the Commodore 64 easy and great sounding. It's amazing. It's not like, hey, taxi, remember that game? Yeah, no, this is good stuff. And the fact that I can pull it off in addition to playing a video at the same time, wow, it just blows my own mind.
The audio rollout, whatever, worked.
No, it never crossed my mind.
But just for a moment there.
Haha. A little more efficient is what I need. Just to give you an idea of how it is really screwing up.
Lots of guys have seen him, but none of them have been eaten up.
It sounds just as good with the bad lines in place than without. I made a new clip of the audio that goes 15 seconds beyond the footage into silence. So, I mean, that's not really checking for the end properly. It's like, okay, if something's effed, end it, right? Oops. Yeah, I think I forgot to load in the magic tables. This is supposed to be zeros and 30s, Mahoney equivalents of 127 and 128. So it used whatever gibberish was there as the index. This won't work. See, this is a 7F and it points to that. All the zeros, though, are no longer 7Fs because I want to make sure I flag these in a special way so the rollout creator will not bother creating instructions for those. In the very first frame has got something negative in every single cell. I'm still not running a risk of it going backwards on itself.
Will you? I'll go get the red ones on top.
As you can see, it hasn't glitched out yet. I hope I can figure this one out. To time something, we started by writing hex 19 to DDoF, and on the way out, we do that, right? But here we got, at 7,000, this is where I'm intercepting it. I'm now using it to time how long it takes to unpack the color. And when it's done, instead of an RTS, oops, it jumps to boobs, which, if you can't tell already, is a temporary. There's boobs, where it's just using one of my indexes to save it, right? It always hangs at the exact same spot.
May?
You see that? So, okay, so instead of jump boobs, we're just going to leave.
May? You're pretty busy looking this way and that way, kiddo.
Okay, so why does it hang when I go to boobs and not? Yeah, boobs. I gotta stop saying boobs. It's fun though. Okay, this is supposed to be just an RTS, but now we're doing all this waste of time increments because, come on, crash, do it.
May?
Ha! It's my sleek color unpacker because this particular color buffer, as you can see, it's all screwing up. It is actually stumbling upon a zero, and that's putting it back to the beginning. And you notice my raster split isn't working anymore. The NMI isn't increasing, like the digi isn't advancing itself because it's stuck in an interrupt, unpacking the color until the end of time. This is good data. I like this. Hail to the boobs. 4 days later, haven't done a thing except think. The boobs problem. This is my color buffer. You don't know what it is because I'm putting only the things that matter now down instead of previous where everything led to the exit. Well, initialize it with this. So as every color buffer has this, whether, no matter where you land, you're going to get sent there eventually. So the holes are filled. The bra handles the boobs.
May?
Yes?
You're pretty busy looking this way and that way, kiddo.
I confidently say there's no chance of it looping back on itself because the very first frame has color information in every cell. Well, yeah, that's true, but only for one of the 8 buffers. The other 7 had random crap there, holes, places that will cause it to go back.
This is the first frame that overflows my 64 pages rollout, and it's happening a lot in this video. So going with 4 pages instead of 2, like 1 color per byte instead of 2 colors packed, I kind of painted myself into a corner here. I'm running another crude hack here that I can get some data from. On the 96th page, we're in trouble. And so any of these that are negatives are bad, like a plot, an advance of 1, a plot, an advance of 2, a plot. Because in the end, you're putting down 1,000 bytes, which times 3 on the rollout is 3,000 into your data stream. That's pretty cool. This is the real task. The task is compressing this so it executes exactly these changes every frame on time, and that was a biggie, and I only have 512 bytes to do it in. These are the biggest challenges. These are the frames that stop you cold or take longer than they should to execute with my current program. That's the means I'm trying to compress. I guess the trick is, can you do it? 4 or 8 buffers, and the player plays each one, alternates without a thought. If it's showing buffer 2 and the Watchdog is on buffer 2, it's not going to fill it until the player hits the interrupt and moves to buffer 3, at which point it knows, oh, hey, it's not showing this anymore. Now I'll fill 2. But the bug, kind of a bug, it's more of an inefficiency because the player is rather fast. So eventually the player, let's make it visual here. Suppose there. So it's really fast, and at some point, the Watchdog is going happily, yay, I can fill this, and the player switches interrupts, and now it's immediately playing the one that the Watchdog is filling. And this is the problem. This is what we've always seen, where the colors start getting corrupted. And this is why, because it's busy filling stuff. Player doesn't care. It moves on. It sets all the stuff for buffer 2, and there it is. And it'll obey the packed color at that moment while it's still being filled in. That's the problem with the packed, having color that is packed. You have to make it so, regardless of when you cut off the data input, it'll still process and leave without falling into a trap. I added just 3 lines of code. So if the player advances itself and it checks, is the Watchdog where I am? If so, increment the border color, the most useful debugging thing in the history of the world. When the background increments, that's when stuff starts to get real. And that's when mistakes start to appear. You see that? It's in there. Oh, there's a pattern to it. What is that, eh? Yeah, I wonder what it means. Everything has a meaning. These are the access times much later in the video. Still following that weird pattern. The mystery of the alternating cycle times.
This is the BBT kind of super simplified for you. But to access the next chunk of frames, 4 frames, that's 1/6 of a second, is a small jump forward. Small jump forward again. But eventually, and this is my fault, sort of, because the audio buffer is so small, it needs to be filled rather quickly, or rather often. And like I just said, the jump is about 100 and whatever megabytes further into the file. And after that, well, the next thing you're going to have to queue up is more video data. So now it has to come back. And you manage to get a couple, groups of 4 frames in memory before the audio data needs to be refreshed again. So now you go forward again. And then you go back. But, okay, it looks technical, but really it's the same simple, say where you want to go and go do it. However, take a look at the estimated cycle times. Going to grab some audio is quite costly. It costs 4 times as much as fetching the video. That is, you got to go get it and you got to come back. So I guess the potential improvement here, if I can make the audio buffers larger, you have to do that round trip less often.
Here we are working on the 2 character set version. Each character set is 256 characters this time because I'm going to try something a little more daring, a little more... I think I can get this to work. I'll show you the screenshot I made. You see how the bottom half, it's yellowy for a while and it's all corrupted, right? That's because the color unpacking is delaying the interrupt in the middle of the screen. Put a CLI in there. Allow the raster interrupt in the center of the screen to interrupt the color setting one that began at the bottom of the screen the frame previous. The packed color, when it's neither here nor there and the interrupt happens, the video matrix and the character set may not be complete as well. They were switched to that data and they still might be wrong. So you're going to get some graphical glitch even though it's not color related. But as soon as that interrupt is finished, the rollout continues and quickly patches the flaws in the graphic data. So on the next frame, it's looking clean again. But seeing a twitch of anything wrong is bad. To solve that problem, and that will allow the Watchdog to stay ahead of the interrupt. The painful process of writing to the BBT without the super CPU. And yeah, you've seen it all. I am writing it over top of, because I've kind of ran out of room in my 32K. Just trying out my 2 character set times 256 character version, and I screwed up again. I had the stripes at the bottom. Damn. I'm redoing it, but faster now. So the new file just has 2K, 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 just the character set that I want. Another 8 hours copying what I just generated to the BBT. Hooray. Come on. It's morning and I'm redoing it again. Before I went to bed, I noticed the BackBit light was flashing rather quickly. That's because the file was, quote, finished. The ST had a value of 66. The 2K section that I'm supposed to be writing to the BBT, well, instead of a loop with B and E on Y, it was BPL. So it copied 128 bytes and then 7 more and then called it a day. I am now comparing. This is actual bytes because for some reason the last 21 characters of this did not make it into the rollout, and yet are they in this file? I think they are. Well, I couldn't figure out what I did wrong, but whatever I'm doing now is working correctly.
Well, yeah, you make one mistake, it costs you time. You make another mistake, costs you more time. I tell you, this whole episode took days, to live out.
2 character set, 256 character version. Finally doing the rollout. And once I stick the sound in here, it's gonna choke. I'm looking forward to the difficulties it'll cause. Long story short, I set it to 00010. Okay, this is the 6 buffer version. Playing minus the color updates because that locks it up. This is the 11,025 hertz audio. And as you can see, it's glitching out. Even without the color updating at all. Yeah, that's supposed to be that and that. So I completely rolled out gibberish values. Nice. So no wonder my color crashed because, yeah, well, whatever. Here I am looking at the raw BBT data. This is where it begins, right here. I want to cut out the relevant bits and reconstruct the BBT so it's not nearly a gigabyte every time I duplicate it, because this is getting crazy on my hard drive. At the moment, the larger audio buffers is not happening. I just specifically forced it to do the 2-3K buffers like before. All right, this is pretty crude, but this is my first optimizing program. Let's see what it does. It starts at frame 6 and loads in the character set, both character sets, top and bottom, and the video matrix for 6 frames ago. So frame 6 looks up frame 0, compares every byte in each character set and the video matrix, and adds up how many are the same, because those are the ones that don't need to be re-rolled out. And if I hold the button here, it'll show me the stats. At the moment, we have frame number of bytes that are the same in the top character set, number of bytes same in the bottom, and the number of bytes that are the same in the video matrix. Now, this is just a simple comparison. Load in, compare, spit out data. What's the good point about this? At the moment, it does nothing. But this is called optimized because I do plan to, after it has a frame and the 6 frames ago, massage the current frame, move characters around in a logical way, and make it so the amount of characters that are the same as the previous character set are, quote, optimized. And I do have a lot of, well, it doesn't really matter. Maybe I'll show it on the screen at this point. A lot of the code worked out. And when I'm done, I think, is it this one? Yes. This will regenerate. Was it this? It's something here. Don't worry. It's a lot of paper. I do have a lot of stuff done on paper. Pretty much the code is written. I just have to enter it and make sure it works.
How did I even do this? Like, once you write a routine and time passes, you forget what you've done. But going back, there was a time that this was fresh in my brain, and I was putting it to paper and then later onto the computer. How did I come up with this? What an effort. I'm proud of myself. Good for me. Past me. Yes. I
think I got my bugs worked out of the optimized 1.03 routine. Da-da-da. And that's possibly part of the reason why it's so bloody slow. It's going to take pretty much the rest of the night, but that's okay. I got my usual Fall Guys to play, and now I have a Commander X16 that just arrived. And take a look. It's under the box because my place is really dusty. It's funny because it was the same price as a PlayStation 5, and I'm going to get more out of it than I would the PS5. All right. It has been almost a day. I'm getting some pretty good data here. Now I'll hold the button to show you the results so far. First column is obviously the frame number. Then the next column is the number of characters in the top character set that are now the same thanks to the shuffling that this routine does. And then the amount of characters that are the same in the bottom character set, which is not shuffled yet. Look how bad they are. Oh, looky here. What do you suppose this is about? What does this have to do with my project? Nothing. But true to form, I am, tinkering around, doing comparisons and stuff. What am I comparing? Well, take a look. That's my Commander X16. Yes. I've already done a quick, simple test. It's about 7 times faster. Why not 8? I imagine because it's got a buttload of stuff it needs to scroll. Look at all those texts. Wow. Kind of cool. Oh, yeah, and there's the case it's in. It's not very pretty. Whatever. After several days, I'm finally got the top and bottom optimizer done. And if I hold the button here, as you can see, oh, look at the juicy similarities. This scene in particular, there's very little movement, and check out the savings we got here. Ooh, that is a lot. As you can see from these photographs here, the top character set did not give me the value, or neither did the bottom, that I was expecting to get on my trial run. Before, I was taking a frame, optimizing it from 6 frames ago, keeping track of the difference, and then moving on. But I wasn't recording it. Because by the time you do record it, that becomes 6 frames later, at which point it's now checking versus the modified version instead of what was normally in the BBT. That might explain why my values did not match up when I did the test run.
Hi.
Now 6045, I put the CLI here, and watch, it is going to lock up with a black screen. Yep. Now I put the CLI here, so it's after the acknowledgement, and I bet you what it'll do this time around, it'll acknowledge it, and then it'll carry through the interrupt properly, because with the CLI first, the moment you release that interrupt disable, well, it's going to flag another raster interrupt because it hasn't been acknowledged, and it keeps going back. Watch, it'll play. Yep. And here's what we got. We added the CLI after the acknowledgement, and a color thingy here and a color thingy here. Now those color thingies, even though we're at 1 megahertz, and this is the, well, this is an older version, but the sound plays and the color corrupts and lots of fun. But because of what I've done here, that color bar you see should never get tainted. And here we go.
May?
Yes?
The interrupts, the raster interrupts, always occur as they're supposed to, even during the berries. And this is what happens if you do not do the CLI right about here.
May?
Yes?
You're pretty busy looking this way and that way, kiddo.
Ooh, and the berries consistently screw it up. Okay, it's nearly 5 a.m. here. I've been working on this for most of the night. Oh, crap, I forgot to load my sprites. It is now doing the optimized rollout for the top and the bottom and the video matrix and the new packed color. Oh, it's very clever packed color. I end it with a CLC, like a clear carry. So when I later am executing these pages, I'll start with the set carry, and then when I find a clear carry, then I stop doing it. But I also am only saving the amount of pages that each frame has generated in the rollout. So it's now just a big sequential mess, but it will save me many megabytes off the final file. Now, once again, it finished during the night. This is me playing the data with Impa Final 1.07, which is totally not designed to do it, but I'm still getting portions of things correct.
We can't be seen together.
There is no disruption in the center. Now I'm going to hit the SuperCPU switch, and there might be. Yep, there it is. To save some time, because this row, here, let me turn it off. That middle row of characters used to be, well, it's common to both character sets. So I have 40 blocks dedicated to the top character set and the bottom, same. To save some rollout bytes, because, 40 characters times 8 bytes, that's 320 SDAs times 2. Take a look at this picture here, and I'll just continue narrating. I ended up making my rollout a little smarter, so when it's dealing with that shared row, it doesn't completely write all the bytes for each character set. And, of course, the fact that I have a Super CPU, because it's fun. Oh, now I screwed something up. I wonder what this sounds like. Oh, that is weird. Well, I better get out of there. Oh, deadly. It hasn't moved a wink. It's not locked up. It's just stopped. I mean, I could probably hit restore and get out of here. Sure.
So it looks like I'm pretty close to the end, doesn't it? I mean, once I have this new color unpacker working, that should be it, shouldn't it?
Perhaps I'll break in right now and show you how it works versus the old one. Okay, so this here is a section of the color unpacker. This little bit of code only deals with 1/8 of the color RAM. We grab a byte, and if it's positive, we loop back. And if it's a negative, well, we'll plot it somewhere between 128 and 239. Well, that's the only time it drops below. Say we have a value of 158. It's actually carefully constructed back in the rollout stage. 158, it might lead it here because it writes the branch target of where it's jumping. And from there, we just plot that many Very specific and very carefully constructed. And then we have one of these for each of the 8 each of the 8 sections. Yeah, I'm screwed. Now, I was going nuts trying to debug this. I've re-rolled it at least twice. The problem lied in my own code, and I looked at it carefully, and as you do, you read more and more into it.
May?
Yes?
Watch how low. See, look at that. The white was coming all the way down to here, and there it was again. Only when the scene changes is it really taxed.
So while I was happily checking out my new color packer, I was playing this version and that version and checking out the differences in the all-important Barry zoom and seeing how far down the white goes. I ended up running into a different anomaly that kind of caught my attention. Now you might see it here in a couple of the versions. Now we have a bit of red in the tree and a little bit of green on the goat herself.
I couldn't figure this out. I mean, I haven't gone too deep into, timing and testing and stuff, but I'm like, this should be fast enough to catch this. Why is it doing that? I suspect because on the one I'm pointing at now, this is the one where I don't do the code that you're about to see on the screen. This particular section here, if it finds something it needs to plot and something else it needs to plot, and the one in between is blank, do this. Fill it in. So you can just do a run of 3. And I thought, oh, this is very clever. What I didn't realize until, a few minutes ago is this is blank only because the last frame and the current frame match. So the current frame might be a completely different color in this middle part. But by doing this particular logic, you are now changing that. This might be the very last video rollout I do on this project. This plays flawlessly. Take a look.
Look at how red they are.
It's a 4-page pack buffer, which corresponds to the 4 pages in color. Exactly. Everything with an F is plot me. Plot that color, plot that color. Things that are between 8, 0, and EF are flags. The first digit is how many repeats of 3. And that is the color. So you can imagine it's plotting 3, that's for the 8, 3, that's for the 9, that's for the A, that's for the B, C, that's the D, B, D, D, and that is for the E. So after it plots all those 3, like groups of 3, it basically just goes ahead 1, sees the 1A, and right there. That's a group of 3, plot, plot, plot. Reads ahead, 1D, jumps here, plot, plot, plot. When it reads a packed flag, the next thing it does is check, did Y cross over? And that will redirect it immediately. A simple test with rollout audio 1.6 goes to 100 pages from 1000 to 73FF. But if the 7100 page is being copied here, 7200 and 7300 are all blanks. So odds are I only need to save 98 pages to the BBT instead of 100, which I have reserved for it. But yeah, big deal. All of that is saving. Wow, that's a lot. Moron, it's supposed to be run 1, not, oh boy. Yeah, well, that's what I deserve. Super CPU, 20 megahertz time, 16 kilohertz audio simulated, not real. And check out the white banner. It plows through the color unpack because that happens, outside of whatever. Well, I took a closer look at my latest, greatest idea, and I don't think it's that good either. So I ended up just changing the values. Wait a second, do I need to do all of these? And if so, it branches to a different section and piles them all down. Otherwise, it'll take its time. That's as far as it gets. And we set the color to, cyan. Next one, set it to something else. So every single one of these half pages has a color. Gets as far as the brown, right? So you're not allowed to do that last part. How about that? And here we go.
chance?
Well, it's May 2nd. It is fricking snowing out. I can't believe this country. Anyways, what I've done here, I had an idea. I let the code execute, but every STA command has been commented out. All the writes are STA DB8 something, comma Y. Now, if you're thinking like I am, the only way that this can cause any trouble is if Y, well, not just Y, if the address crosses into the DC hundreds. I was thinking, oh, big deal. The first 16 are the sprite pointers. No, that's D1000. DC00 is super critical. What is that? The CIA chip or whatever it's called. You do not want to be throwing random pokes there. So that's a clue. I think I figured it out. Oh, man. I am now looking, obviously, at the monitor here. Now, in this case, in my source, I changed all the DBs. Like it was DB8 something. I changed it to D88 something, thinking that maybe it was going over into the DCs, right? And when it crashed at D8 something, I'm like, why? That does not make sense. So before I went too far, even though I have been, going at this for some time, I thought, hell, just bring in the monitor, find the damn code. What is this, right? So, and then it turns to trash. Big clue? Oh, it happens to be at 8800. That. Let's see if I can find it. Man, I got so much paper here. Yes, it's my fault. Oh, that's glorious. I can fix this. Oh, man. I mean, I can shave some bytes, do something. I'll make it work. I'll make it fit. It'll work. Whether or not this plays or not, I really don't know yet. I think it will. I totally think it will. I have the volume turned up, so here we go. I feel similar to when the Wolves in the BackBit wrapped up. I feel just a little sad. There's something about it. It's like completing a puzzle, like a jigsaw puzzle. You got it all on the table. You put the last piece down, and you're satisfied for a moment, but then you're like, I want my table back. Why did I bother doing this? What a waste of time. Maybe. I don't know. Does that feeling resonate with you guys? Like, do you feel like that? Do you understand where I'm coming from? Like, I'm not upset that I did this project, but now looking back, it's like, I spent so much time doing it. But look what I've done. Huh. Has it ever been done? I don't know. I guess I'll find out. Somebody will comment, hey, so-and-so did this like in 2006. And I'll be like, oh, crap. I did the final tweaks to the files, and I've also now linked them with the basic stub that I wrote, and it basically runs the machine language version, right? There's the size. So it's 273 megabytes, right? Now that's full of a lot of fluff, but the final file is this, 73 megabytes. 73.7 for the 8 kilohertz audio, and the 11 is 77.2. It's a little larger because the audio is bigger, right?
May?
Yes?
You're pretty busy looking this way and that way, kiddo.
We've got to make sure nobody's watching us. We can't be seen together. We have to be on the lookout. Ah!
What?
Look over there!
What? What is it?
Berries! There! Look at how red they are!
Yeah.
They look so good.
Do you want me to go pick some for you, kiddo?
Will you?
I'll go get the red ones on top.
No thanks.
No?
That's okay.
Why not?
Wolves don't eat berries, do they?
Sure. Wolves eat berries.
They do?
Yeah, some sometimes.
Really?
Really.
Oh, I'm so glad to hear that wolves eat berries too.
I picked a lot. Want to find a place to eat them?
Yes. Yum. These are so good. How lucky am I to be sitting here next to you, eating these berries.
Here, you can have all of mine, too.
Are you sure? Thank you, Gabu.
Glad you like them. I think I like meat better than berries anyway.
Oh, so you're thinking I'd be a tasty lunch.
What? No, it never crossed my mind.
But just for a moment there, didn't you think that I'd be pretty good to eat?
No! I mean, well, just a little. No way! I wasn't thinking like that at all.
I wonder. I bet you thought I would be the tastiest goat around.
Well, yeah, but then... No, never! I would never think like that.
Gabu?
Well, yeah, I guess. But it was just for a split second. Honest, just one teeny tiny split second.
That's what I thought. Goat meat is supposed to be tender and juicy, right?
Yeah, you said it. Tender and juicy. No! What are you trying to get me to say?
Just what I thought. You're a wolf, and you're thinking of gobbling me up one day.
No, you're wrong. You are a very special friend, and I wouldn't ever think of eating you. Besides, I don't even like goat meat.
I don't believe you.
I'm telling the truth.
I still don't believe you.
But it's the truth.
I just don't believe you.
You've got to believe me.
Okay, I believe you.
Oh, there's nothing harder than trying to convince a friend to believe you. Try standing in my shoes sometime.
Stand in your shoes?
Huh?
Okay, you're on. How?
What?
I made a wolf.
What? What are you doing?
I'm going to eat you, Gabu the goat.
What?
Growl.
So, what's this about the legendary white wolf?
Well, they say he's really something.
He's big, white, noble, and strong.
He doesn't belong to any pack. A true lone wolf. His eyes are piercing and can freeze his opponents.
He's ferocious, heartless, brutal, and wherever he walks,
Even the weeds die and never grow back.
And you guys believe that kind of talk? Waste of time.
But it might be true, buddy.
Yeah, lots of guys have seen him. But none of them have been eaten up, have they?
No, wait, buddy!
Wait for us!
I'm a wolf.
Yes, you are. And a very cute wolf at that.
A cute wolf? A wolf's not cute. I'll tell you what a wolf is. A wolf has sharp, pointy eyes, and an ugly nose, and a humongous mouth that drools.
Oh, is that the way we look to a goat?
Yes, wolves are scary and disgusting.
That's downright awful.
Right! That's the reason we're gonna play this game. Growl!
Reason? What reason?
No more questions, goat. I'm gonna gobble you up. Growl!
Uh-oh! Help! Help! This goat is gonna run away!
You won't get far, Goat. I don't walk, and I'm gonna catch you.
And that's it. Our coding adventure is now at an end. Well, I must thank you for, being there with me, for watching as much of it as you have. Perhaps you've seen it all. That would be, wow, that would be dedication, I tell you. Hopefully you've got an appreciation of what the Commodore 64 can do, what the BackBit can help it do, and what one person can squeeze out of the Commodore 64 with a little bit of determination, perseverance, and inspiration. And of course, the great things that others in the past have made possible, such as Mahoney coming up with this digi method and so on. Yes. So, well, what's next? I don't know. I mean, there's ideas. Everybody has ideas, but everything costs time, and you only have so much of it. And I realize that. It's like there's not enough time to do all the things you plan to, not enough time to play all the video games you wanted to, read all the books you hoped to. Not me, I don't read much. But yeah, you know what I'm saying. So it'll be a long time until I post again, if ever. But I'm still proud that I managed to get this one out. And I tried my best to make it an entertaining series for you. So I guess this is goodbye for now. And until next time, I'm Luke Darksnout.